Yeah.
No, but that makes sense. Like, sign up like this. And
Yeah.
No, it's flat. It's just the midline thing.
Okay, folks. Okay, folks. So let's get on with today's lesson. I have to share with you a gripe I have about Peterson. Maybe you share the gripe. This is the form that we did in our class, but Pearson expected a different form, didn't it?
Oh, yeah.
They what form do they want?
The T and C.
It's not that they were switched.
Well, it's like
It's like they took the parentheses and distributed, right? Didn't they say that they wanted this form?
I know.
Okay, so we have pi over 6 times, oops, I forgot. Pi over 6t plus pi over 6 plus 11. Do you see why I prefer the first one?
Yeah.
Why?
Yeah.
It gives you,
The V value.
yeah, well, they both have a dilation, right? But here it's just-
horizontal shift.
Yeah, the horizontal shift is kind of hidden, isn't it, in the other form? So in our class, we are going to be using this, although you're welcome to give me whichever one you want. My recommendation is stick with this one so we can see, oh, this graph is moving, yeah, 1 unit to the left. That's specific, this is sine graph. Or in this one, this cosine is moving to the right. We can see that that's going this way. As opposed to if you were to multiply that out, you have like pi over 3. It's not moving pi over 3, it's moving by 2. So I don't know. I just have a little bit of a problem with it. But I'm sure you were able to adapt, right?
Sure.
I hope so.
I was able to.
There weren't a lot of tears.
One.
Just one tear. Okay. I think Ariana had a song about that.
No more tears.
Yeah, no more tears. Yeah.
Wow, Ariana's run the first.
Yeah.
No more tears.
Great.
Okay, so today is nothing really new. It's just a way of pulling everything together. We're going to be just doing some modeling. So I'm going to give you not like runway modeling, but you're going to get a graph and then you have to make a function from that, right, Jonas? Make sure to focus up here.
Yes.
So either you get a graph and you make a function, or you'll get some data that you're going to make some sort of function from that. So this first one is I think it's super easy. Could you show me the period of f?
It's 2.
Yeah, the period is 2. Would you please take a moment just to discuss with your neighbor what the frequency is and what that means in this context?
How many times? Yeah, how many times do you think how many everyone perfect. Repeat once per minute is fine. You can see it.
Okay, so from the 2, I'll just look at this, right? And the 1/2, explain to me. Yes, I'll
It means that like there's one of those like sine waves for every 2, like, for every 2 on that side, right?
Are we good with that? That's all it is. Right, it has nothing to do with this x value or 1/2 that's nothing. It's 1 sine wave per 2 units on the x-axis. So it should be something you could actually see. This one, thank you, Augie. Example 2. Which of the following represents the constant c? Well, this is a cosine. On a count of 3, I'd like to hear your answer. 1, 2, 3. C. And would negative pi over 2 also work?
Yeah.
It actually happens to work here because either way, I see that pi over 2.
Pi over 2 or minus pi over 2.
This.
Yeah, cosine.
You moved it that way.
Wait.
Yes.
C.
It's C, because our cosine is a C.
Yeah, C.
Yeah.
Negative sign and it starts with the Y after.
We could think about it as negative cosine, in which case it would be no shift. But this is positive cosine.
Oh, moved it down.
Yeah, it's not, yeah, and it's moved down. So Jonas, you gotta control that. All right, so we're looking at this wave right here. Either that wave, or if you wanted to, you could look at this wave. Just we're looking for some sort of positive cosine. But in the context of this problem, it is looking for this. So that's why, yeah, putting a pi over 2 there says moving to the left, pi over 2. Yeah.
Yes.
Yeah, this is an interesting one. Here's a yo-yo that's, of course, on a string, as yo-yos are. It's attached to a 30-inch long string. It's rotated at a constant rate. The figure provides a representation of the yo-yo in the XY plane with the direction of rotation indicated. Okay. At time t equals 0, the yo-yo begins to rotate. The yo-yo is at the start position in the figure. See that? At time t equals 5 seconds, the yo-yo is completed 20 rotations, and the yo-yo is in the same position as it was at time t equals 0. A sinusoidal function is used to model the x-coordinate. So again, model the x-coordinate of the position of the yo-yo as a function of time t in seconds. Which of the following functions is an appropriate model for the situation? I'll give you a moment to think about this. And don't go directly to this. Maybe think about what makes sense first. So take a moment to discuss.
In 5 seconds. When you do, I think it's D. I think it's so like because every you get divide. You divide. What is the 8? You 4 times 2. Each period would be a quarter of a second.
So you find any.
So that. Right. Yeah.
Like.
Take five. You guys, talk about it. Is 5 each 5 seconds to work.
Okay, you have to do.
The period, yeah.
1/4.
So that's a B is equal to 2 pi. And when you cross. No, so you get 8 times. 20 is a rotation for like 5. Yeah. And the equation.
Why did you not know? Because it's like, remember, like, we learned like.
10 more seconds.
Figure out which world is it. It's
Okay.
yo-yo.
Yeah.
Wait, but why do you need?
Okay.
You put pi. Because.
I'd like to hear some thoughts. You had some time to think about it. I just want to hear what your thoughts are. Lawrence is not in this class, sorry. This is 6th period. Emma, any thoughts on like what to do here? What did you see? Okay.
Because if 5 seconds equals 20 rotation, you want to find the rotation.
Okay.
That comes back to the original spot.
So we're okay with that with 1 rotation is a period. Okay. And what did you find out from there? So 1 rotation is 1/4.
4.
Mm-hmm.
Oh, it would be 2 pi divided by 1/4. 2 pi.
either divide by 1/4 or we could multiply by 4, which gives us the 8 pi, which gives us which one? D. So you change your answer midstream. Okay. No problem. Are we good with that? Nicely done. Yeah, it was all about the period because everything else here is the same. Why are they using sine?
Because it starts
Because it's a
at
circle.
the bottom.
Does it start at the bottom? Is that what sine does?
No, it's cool.
Difficult.
We discussed why are they using sine here? And why is it positive? You can do it every.
Because
It's like-
it goes.
Makes sine or cosine, it's sine.
We always got these.
Yeah, that's why.
Yeah. Oh, because think about rate of change.
Yeah, it goes counterclockwise. Counterclockwise.
But zero, from 0 to x.
Just look at the maximum minimum.
Oh, I know. And then right now that.
It starts by going positive.
Yeah.
And then it's positive and decrease.
Yeah, because this is like. Wait.
Sometimes I would think guys, positive to decreasing the because it doesn't start by destroying.
Okay, folks. So who'd like to tell us why are we using sine here? Sine for Simran.
All of us, we talked about how it's gonna be sine because we know like concavity, and also it starts by increasing and the rate of change is positive.
Okay.
Instead of it's
But
increasing,
what's increasing?
the y value.
Okay.
Yeah, they're increasing, like, or the graph is increasing,
Okay.
and then it's increasing, but at a decreasing rate. And then it's just like going up and down, basically of concavity, and that when you draw it out, it looks sine.
Interesting. Okay. Any other input? Yes, Connor?
I don't know.
Oh, thank you. Okay. So something seems off, but you're not sure how to put it into words.
Oh, because both cosine and sine.
Concavity and increasing, decreasing. Yeah. Yeah. So what locks it into sine, right?
It'd be cosine.
But lots of.
But so I think that's the question we come up, isn't it? So
Yeah, so it has to be, and we know it's.
sinusoidal has to be sine. Are we, is that true?
It's gonna start by increasing.
Does it start by increasing?
And so it has to be cosine.
Or what's increasing? Oh, but we're tracking the x value. Any?
Well, I was thinking since I'm bought like the y value of the radius, like it's just kind of tracking.
The
Like,
y value would be the radius, so, oh, of our function, okay.
So. Like that would be a triangle, like I
Okay.
would give it in triangles.
Okay,
I was thinking like,
there's definitely triangles involved,
Is the
okay.
y-axis.
What's that? T is a time axis, so as time continues, right, as time continues, all the yo-yo's going around.
The x coordinate in that function.
Yeah, and what are the coordinates right here of this? Oh, what did I do?
Goes from 0 to
Zero.
30 to 0.
0 comma 30, negative 30, right? And this one is 30 comma 0. And since we're tracking the x coordinates, that means our graph has to start at 0, which is a midline. Right? We're going from 0 to 30
Oh.
to 0 to negative 30 for the x coordinates. Does that make sense? We're going up to 30, back down to 0,
Oh, that doesn't.
and then it's going to go to negative 30. And this happens when time is equal to
1/4.
1/4. So I just want you to take a moment to actually see that x value changing, right? It's going to 30 to negative 30. I'm sorry, 30 to 0 to negative 30. As this goes around, it's going to, the x value just kind of goes like this, doesn't it? 0 to 30 to negative 30. Does this oscillate back and forth?
Yeah.
Would you please discuss if we were to do this in terms of cosine, what we would do, like what would the equation be?
30 line.
I feel like in terms of cosine, you have to think about that. You have to shift into the track side.
And I should say Y value. I should say the Y value.
Right, Sam.
The Y value.
You just put plus pi over two in the
Watch it.
No, you just put pi over two in the parentheses.
Yeah, that is a thing.
That's not.
But I think that's
No, it
true.
still works.
But I think
35 and pi
So like, you're right.
pi
Yeah.
over two.
I don't know what you would do with
Yeah.
I think it's like, then you would, I think then you would start at 30.
Or.
That's what I think,
You just add pi over
because then the.
You just
the
put it
Y
in the
value-
parentheses, you just add.
Wait, are we looking at the Y value?
Or the Y value.
Oh, yeah.
Say that.
Why now the one?
Yeah, I'm so sorry. I asked the question poorly, didn't I? If we're tracking the Y values. We're tracking the Y
It
values.
starts at 0. Wait.
What's our fundamental wave gonna look like? The first period, what would it look like? If we're tracking the Y value, start at negative 30,
Yeah.
Go to zero.
Wait, okay.
go to 0. Show me, what are we dealing with here?
Oh, you're doing with a negative.
Dealing with, right, the negative cosine, we start down at the bottom, come up. So, and then, of course, instead of 30 would be negative 30, but the period, of course, is the same. Emma,
Why would we be looking at the X values negative sign? Pressure is really long.
well, the question is saying to use a function, either sine or cosine, to model the X coordinates.
Oh.
Now, if that changed to the Y coordinates, then we have to have a function that begins at the bottom, negative 30, and goes up to 30, and they have to do this kind of negative cosine. Yes.
Asking to, like model X coordinates will be sign and as like most functions that we.
That's a good question. So will the X coordinates always be sine? Be careful about always, right? If the start position were different, everything would change, wouldn't it?
Like if it started at.
Like if it started anywhere else. Yeah, Elgin.
So like where it is or at the top of the program, it starts at like X is 30.0 or negative 30.0.
So if it started up here,
That would also be a sign.
it would either be sine or cosine.
Oh.
So if we're tracking the X values from here and it's going this way,
Then
That is.
so we have 0 to negative 30,
Negative sign.
negative sign, right? It's flipped.
And then 30 functions.
Yeah.
if you started at the top.
Over here on the left,
That's
your
negative.
side, right? So every question's a little bit different.
Okay.
Just like, where are you starting? Where is it going?
You have the X values twice.
Perfect. Yes, exactly. And Kaylee and then Oliver.
If you started from 30 comma 0, would it should be a regular cosine now?
Yeah, I think, wait, 30 comment right here?
Yeah.
Oh, it would mimic the unit circle, wouldn't it? Because that's where everything begins, the unit circle.
And then if it were negative.
Oh, just a minute. So Oliver and then Max.
Wait, why for a sine function do you track the X values if like sine normally corresponds to the Y values?
And that's on a unit circle. So this is, we're detaching from the unit circle, saying we have this function, we have this function. Now let's make it model something completely separate from that unit circle.
Okay.
So the periodic functions kind of come from there.
You can ask for X or Y.
You can ask for X or Y values. Yeah. Right. It's confusing to say, okay, we're doing X values. Well, yeah, X values normally correspond to cosine, but this is off the unit circle. Great question, man, Max.
So sine and cosine graphs really can model like X and Y values for these types of problems.
Yeah.
Yeah, so if we were like, we chose to model like the Y value, like what would that have been?
Depends where you start.
Okay.
Right. If we start here, that Y value is what, 30 comma 0. So we would start at 0, we'd be starting on the midline.
Oh, so that would be like a sine.
That'd be a sine graph. If we start here, that'd be either sine or cosine with some sort of shift. Yeah, we're not gonna do that. But let's take what we have so far and build a little bit on it. You guys are asking all the right questions, so kudos to you, and I appreciate your deep thinking. Example 4, I'll give you a little bit more chance to think about it deeply. It asks for A and D. I'm gonna ask for also B and C. A and D should be quick.
Yeah.
Go ahead, start discussing. Do A and D first. They should be quick. Should be fast. Discuss at least A and D, please.
Okay. Shit, I got. 1.9, shift 5.9, sine 30.
Or, no. It's.
Write it out first.
Yeah.
How you get through that?
And then 60.
Oh, yes.
Okay, wait, so B is pi 60,
So-
right?
You know, wait.
So, wait, no, and then that would be.
Because you go from max
Zero.
you have to go to max.
Oh, wait.
Yeah, that would be.
Yeah, it's wait, 52 is the max.
18. Who's here?
It starts here. Okay.
Yeah, the midline is 60, so yeah, plus 60.
B
Plus
is,
40.
sorry, C is, you moved it to the left, so plus. Get that?
So you do the plus 30.
You want to start on the zero, so you move to the left.
You have to go zero.
No, two minus. Wait, what?
I got plus 40.
Oh, wait.
Yeah, you're.
But then you have to make the 9.
I got five.
So you got 8.
Did you get?
The one that- yeah.
5 or 30? No, wait, I got.
I got 50 because normally it's zero. But in this case, I'm getting maximum.
Oh, yeah, yes.
I call on someone in about 15 seconds.
And then I just did it. Plus.
Wait, yeah, you have to move to the other way.
Okay, finish up your conversation. Finish up your conversation.
Oh, wait, no.
And that is it. Okay, so I'd like to hear only about A and D from Nathan. Can you help us out with this, please?
Help with, which one, sorry again? A and D?
Yeah. See if you were listening after I said. Go ahead.
So what I started with,
Yeah.
alright, first thing I did was like, I found, periods basically.
Oh, for A and D? Oh my goodness. It's the first question. What are the values of A and D? So we're here.
Okay, so basically, it's
Start
asking
equation.
for the amplitude and like, okay, alright.
You're on board?
The amplitude, basically, all I did was I just did 70 minus 52 is 18, and I just divided that by 2.
70 minus 52 is 18. I think. Is it 18?
Yes.
Yeah.
Okay. Yeah, 18. And then what do you do with that?
Divide that by 2.
Divide that by 2. Okay.
Yeah.
So A is equal to 9. Okay.
Then for D, basically I find how much it goes up on the Y.
Okay.
So, I,
I see. So you're focused on B and C, is that right? Uh,
Actually, before you are.
well, where is it? Like, you see where it is on the graph? Like,
Oh, sorry, it's just in between the two, so
like, what, is it closer to 70 or closer to 52?
it's in between.
Okay,
It's
anywhere in
61.
between? Pardon?
61, because it's like.
Oh, 61. Okay. Just,
line, so-
are we okay with that?
Yeah.
Yeah, thank you. And how did you get that 61 exactly?
Midline, so like the midline is like basically like how much you go.
I want to hear the numbers. Like, how do you get
Oh,
61?
because it's just right in between the two.
Okay, I want to hear the numbers.
Okay, 70 plus 52 divided by 2.
Perfect, thank you. Are we good with that? Either that or subtract 9 from the top or the bottom. Either one is fine. I just want to make sure that we have it. But I think we just had a sense of it, so sometimes it's hard to play with. So thank you for getting. Okay, thank you, Nathan. I do need to hear about B and C as well. Yes, Max.
Okay, so for B, I got pi over 30.
How'd
And
that,
I
how'd
know
that
this because when like plotting the points on the graph, we know that 0, 70 and is like a maximum and 30, 52 is minimum. So it must go up to like a maximum again.
Okay.
Making it like a cosine graph.
Huh.
So we know at that point it goes like by 60 points. Like the period itself is like 60 points.
Nice.
So you do 2 pi over x equals 60 to get like the actual b value. And for that I got pi over 30.
Okay, I think I kind of twisted around what you said, but it happens. Pi over 30.
So I got like a different answer for the C.
Okay.
Very similar to what everybody else got, but
Oh,
I got it's plus 45.
okay.
Because when you like draw out a cosine graph, like you you need to start it like it needs to hit the midline.
Wait, so if you say T plus 45, that means you're going 45 to the
Yeah.
left. Okay. So really,
So if you shift that over, it
So-
should line like perfectly.
okay. Okay.
Oh, yeah, that's what I was saying, -9.
Yeah, can you keep like that? You can do minus 45 or plus minus. Can do
I feel like both work.
Now, plus 45 would be great. I think that comes here, doesn't it? If we go to plus 45,
That'd be negative.
that would be a negative sign.
Would it be?
So yeah, finish it up.
I think C should be plus 50, T plus 50.
Yeah, I think either 15 would work or T minus, yeah, minus
Why
45. Going over here.
Oh, because it's the sign graph.
Then plus 45 would be the top figures, and that would be negative.
Here, one moment. I got Nia and then Augie. I'd like to hear Nia and then Augie. It's really good discussion on here. Only Nia and Augie now. Okay, sorry, man. A little bit later. Yeah.
2 minus pi over 2. And I got that because the sine graph starts at the origin, which is in the graph. And if we move it up 61 units, which is the midline, and h is 0 to 70, that's like already at the maximum of the sine graph.
Okay.
And to move to
Maximum.
the like maximum of that graph, you would add like pi over 2 because that's.
Well, be careful. I'm sorry to cut you off here, but be careful. We've changed the period. Pi over 30 changes the period. We're no longer going from 0 to 2 pi. We're going from 0 to 60.
Oh,
So we had to base it based on that. So it sounds like you have a lot of good analysis going on for vertical work. We just have to make sure we're in seconds or minutes land here.
set it up fine.
Well, it tells us 0 and 30 and 60. So we know that the period is 60. So I should be counting in terms of minutes instead
We
of
know it's a quarter.
pies.
Oh, so I would divide 60 into 4 pieces.
Exactly, yeah. Yeah, Augie then Max.
So I'm just curious though, because like I think I got -9 sign and then it would be minus 15 in there, which I think that still works.
Yeah.
But is there like a way you prefer us to like represent it? Like,
Oh, no. And these are great. There's multiple different ways. Yeah, the maximum is different.
Wait, so I don't understand why it's T minus 45 and not T plus 45. Because if you do T minus 45, you're moving the whole graph to the right by 45.
Yeah, and that's fine. Because what we want is sine. We want it to be this, like going up.
Yeah.
So there is this over here, but this should be a negative sign. So we have to go all the way to 45 to get the full sign over there.
But if you do T plus 45, do you not shift it to the left and start at the 60 now?
If we go plus 45, that means we go to this. I'm sorry, I didn't anticipate going to the left so much, so I didn't.
Oh, yeah.
I don't have this, but I hope it makes sense that if this is 15, then this would be negative 15 over here. This would be negative 30, and then this would be negative 45.
Oh, wait,
Does that make sense?
Yeah.
So-
Yeah.
So you can move it over to left 45, but just make sure you're doing negatives over there.
Yeah.
That's the last one we had to move on.
If you do plus 15, then you're gonna have not a negative 9, right?
Say that one more time.
If you move it to the left by 15, then you're not gonna have a negative 9, right? I feel like that's easier.
Yeah, this is the one I would go for.
Yeah.
The closest side is right there.
Period never changes, so
Yeah.
you draw it as like regular sign and then just plot the points, then move it to wherever it's at.
Perfect, yeah.
Okay.
And whether it's sine or cosine, the period's gonna be the same.
Yeah.
Oliver, you bring something different here? We need to move on.
There's two correct answers.
There's about 8 different correct answers. Because there's plus, minus, there's different shifts, there's sine, there's cosine.
There's multiple.
There's infinite. We don't have time to go over all of them though. But you're right.
I don't think
that's
it's.
one of them. You're probably right.
Yeah, no.
Okay. Okay. Example 5. This should be quick. So again, we need to move on. You guys are talking. This is not a calculator problem, by the way, and it should be pretty quick.
It's a different number. Okay.
Discuss if you haven't, and it should be quick again.
I'm not checking it out. It was on my.
This maximum. Plus or minus.
And the maximum. Wow, how do you know February 3rd? You seem really excited about it.
I'm very excited. To be in the past too. Okay. Yes, Stephen.
Oh, so I think the answer to the question. Back to question.
Seven.
Yeah, I
Yeah.
met.
5 more seconds for a discussion.
Wait, Simon, I don't understand.
Okay. So Nathan's volunteered to give us some insight and a question. So I'd like to hear only Nathan. Yes.
Well, I said it was D because it's just, 25.7 is the amplitude and 61.2 is the midline, so if we just do 61.2 minus the amplitude, we get like the minimum.
Are we good with that?
Yeah.
Yeah, we don't have to do any calculations here at all. We just have to understand what a sine looks like and how the midline and amplitude work together. Yes. And
Also, like, how would we find like the minimum average monthly temperature in terms of
like, how would you find when that happens?
yeah,
Is that what
like
you're asking?
how would we like?
That's a great question. And we'll get to that in just a moment. Looks like Joe just has a question, but thank you.
I was gonna say about this.
Oh, yeah.
I was gonna say why, how you can solve it, but if we're gonna get into it, maybe not.
Okay, well, yeah, so are we good, first of all, that the minimum temperature is that this is actually a pretty straightforward problem. And so we get this C. So Jonas, I'd like to hear your input about how you would get the month.
So for things first, you need to find the period, which if you calculate, it, I think comes out to 12.
Okay,
Uh,
that makes sense.
and since the graph is shifted over to by 4 to the right, and it starts at on sine, you assume that it's 4 right here. And so if you split 12 into 4 parts, you get 3.
Okay,
And so the maximum would be at 4 plus 3, which should be 7, and the minimum would be at either 4 plus either 7 plus 3 and then plus 6 again. So
so you have this kind of thing going on, right? You have this midline here. Excuse me, I messed this up, didn't I? Wait, so it goes up there, then down here, then down here, and then up at like 16. I guess it would be. Does that make sense what he's saying here?
yeah,
That's
and,
nice.
and so B would not be correct because the maximum would actually get 7. And D would not be correct because if you continue, they're basically just the same. If you said the minimum was at 1 and the maximum was at 7, they would be correct.
And we could see that answer here that and would be, well, we're looking for a minimum, right? We're looking for the minimum. Right?
13.
The question is, when does this happen? Either 13, or we could move it back into our normal range by taking the 13 and subtracting 12 to that 1. That was a really good insight. Thank you. This one is a calculator problem. It says regression.
Probably not.
You never know. Gotta be ready for everything and anything. And all.
Any-
Does anyone need a calculator?
Okay, yeah.
Mine's like about a 9.
Plug it in.
Yeah, that's not a good word, Nathan. You should not say that.
Did you what? If I had another one. Did you?
Oh, it's like blinking red, like it really doesn't.
You can use mine.
It's okay, nice. I'll share it with you.
No, because
It looks like you're gonna have the, let's start with your neighbors. I don't have any. So.
That's not always good.
actually, my calculator.
Function n gives, oh, this is. Oh, do I? What is the
Yeah, you just like put it on.
Okay.
Bro.
Just plot it off.
You just kind of show the direction.
Yeah, wait.
Okay, so,
I don't even remember.
wait, I remember. Zoom.
How do you actually get?
Oh. Edit.
But
No, it's step.
You know what?
Iteration, what does that mean? It's for this.
Like, those are gonna be.
What's up here?
So wonderful.
I heard-
So we just schooling, you know, so.
Oh, 16.
Who's a-
Would the period be 12 for this?
Is it asking for the period?
Yeah, that's a leap period.
Oh, I must.
All right, there you go.
Secondary. These are really key.
Oh, what's the period?
But yes, I like just felt like it was.
Side is so reversed. It's right. Okay. That's it. How do you? We put it in period?
Sid.
Wait, do we need to put it in period? Oh, just like.
It's asking for it.
Okay, so I just scored second race. No.
Wait, that's T have to be
Y equals.
Yeah, I did too.
Oh,
Y one.
yeah. Calculate. We did it.
Get the maximum?
No, at first we got the regression.
Yeah, we don't need it.
Yes, we got it.
We got it.
Okay, so now let's just write it. Okay, so graph. Oh my god, that is so cool. That is so cool. This is, I love how.
Every time you learn something new, it's like you fall in love with it a little bit more.
It's like iterations, that mean like, it's in reference to, you can see like how it's just.
I was like that.
We did it.
Anytime we get that,
You go right with that different exact.
Oh my god, right now.
So it's not just like.
I just put that in.
Wait, we gotta just figure that out from the.
We store the equation as one.
You put in the numbers, it's top.
I don't think we need this graph.
Oh, yeah. And it's like 11.
Wait, how come the max? Why is it well? Wait, yeah, how come it be 11?
No, I haven't.
How come the max be 11? Why? Because I still
there it is. For some reason.
Exactly.
And for some reason, go to the.
I will draw.
Yeah, no, it's crap. Very good.
You know what I mean?
If it doesn't, then they will do.
No, I did not.
Think about it, you make it a good point, look, the max.
Round up.
Yeah, but it's like, it's all from max, so it's like.
You guys remember the good Zoom? See all your.
You're right, do that.
You remember the good Zoom?
That number could compare.
Stack.
Look, it's invisible, that's why.
Second.
You know that invisible.
Okay, that isn't working?
It's not the big. Here we go.
Oh, that's weird. Did you,
Wait, do we got input anything for the period?
okay, so we get y. Is that what they got? Yeah, Connor. Just one decimal point. 3.1. Uh-huh. I'll see, but it's X probably over there. Okay. Okay. 8 point. Okay. Did we get this?
Yes.
Yeah.
You got it, right?
Yeah.
Okay, so of course, to get this answer, all you do is, do you have to use like max function on your calculator?
You can add the 10.1 to 8.1.
Or just add the two numbers together? It seems like that'd be a lot quicker. Sorry, Max, we're not gonna use you for this one. Yes.
Wait, so for our period, do we put 12 or do we put 16?
Yeah, well, the period is, it's a nighttime hours in a year, so the period is 12. And the iteration though, like what is iteration? We haven't spoken about that before. Iteration is something that your calculator allows anywhere from 3 to 16, and the more you do it, the more accurate your graph is going to be. And just iteration means how often does it change course. So it's the least jagged of all the different types. In general, just do 16 because it's like always. I think it asks for iterations. Didn't ask for it in the stats. Yeah, so yes.
11.
Right, we look at the best answer, and for all of these 11.3, this is the best.
Okay.
The actual answer is 11.3, I don't know.
Yeah.
Why would you round up?
If there's like. Cause I heard some discussion, like obviously on the chart, you can see that like 11 is 4 and 11 is not on there. Like, it would be up to our best judgment if we wanted to round up or around.
Exactly.
'Cause-
Yeah, it's
Up to
11.8.
your best.
Yeah.
So, yeah. Yes.
Don't you no matter what one like round up, because if it is 11, like how you always say, like it has to be the maximum, like there can't be any points over it, so it's better for there to like. So like there not to be any data point that go over the maximum, so 12 is better.
Well, I don't know if it never reaches 12, I don't know if that's appropriate. So it's open to interpretation.
If it was like.
Yeah, but we do know that.
And people might, it's not the best question. It's just get a feel for it. We do have to do the quiz. Haley, do you have a question?
All right, we got.
Guys, check the bill.
I mean, degree.
Oh, no, it's the cool thing or?
No.
It's not.
What happened?
We had to get rid of that machine.
Wait, my turn.
Wait, already, what happened? Stuff. Oh, that's so sad.
I know, I love that.
There's 12.
our calculators.
No calculator, just one between you.
Oh my god, that is.
Oh.
7. What's the six? Give.
Right.
Stop.
Yeah, that's the same. What do you mean?
Yeah.
Well, I'll start together, of course. Let me get the timer ready. This will be a 16-minute quiz. Give me just a moment. Got to set this up. Ready for success? Yes.
You green and red or blue? You green and blue.
Blue. I was great.
If I use a red pen for like to mark the answers, is that okay?
You could probably borrow a pencil from someone.
Oh no, I have a pencil. I was just like go back.
Oh, sure. Yeah, that's fine. Yeah.
Thank you, sir.
You guys ready? Ready or not? You can always do the honor code after. 5, 4, 3.
2, 1.
Have fun. What 2, 1? Have fun. And the first point is -4, 3.
Wait, negative?
-4, 3.